Vale, okay. Thank you for the invitation, Julian Maria. Thank you for coming. This is a theoretical work, so if you understand something or because of my English, okay, or if you have some questions, please ask me, right? This is a joint work with Pedro Calleja from the Universitat de Barcelona, and the name of the talk is Non-manipulability by clones in bankruptcy problems. And in particular, in this paper, we provide new axiomatic characterization of the proportional rule in the framework of bankruptcy problems or rationing problems. Okay? So making use of a weak form of non-manipulability property that we call non-manipulability by clause. Right? Okay. Rationing problems deal with situations where there is a set of agents, firms or I don't know, countries or whatever, that have claims on a perfectly divisible resource in such a way that the total resource is not enough to satisfy all demands, right? All things. For instance, the classical scenario is a firm that goes into bankruptcy, and the liquidation value of the firm is insufficient to satisfy all creditors, right? So the question is how to distribute the assets of the firm among the agents, right? Okay, another situation could be the distribution of CO2 rights emissions, okay, among countries in order to mitigate the negative externalities of the emissions. And on this topic, Chechu and Cory have different papers, right? Another possibility is, I don't know, is the distribution of water among an irrigation community, okay, in situation of water scarcity, right? Or the allocation of the cost of cleaning up a polluted river. Okay, there are a lot of situations that can be represented as a bankruptcy problem or rationing problem, right? So the ingredients are a set of agents, and right, and the state is the total amount to distribute among agents, and a vector of claims. Under the assumption that the aggregation of the claims is strictly greater than the state or the total resource, because otherwise the problem is trivial because each agent obtains his claim, right? Okay, so and these kind of problems are solved making use of rules, bankruptcy rules. A bankruptcy rule is just a function, okay, that links bankruptcy problems with vectors, okay, and propose a recommendation on how to distribute the total estate or a fraction of the estate. Okay, for instance, the equal division of the estate among agents to share equally the estate is just a bankruptcy rule, or even to give nothing to each agent is also a rule, according to this definition. Okay. Of course, a natural requirement is to impose budget balance, which says that the total resource should be distributed among agents, right? If you have some questions, please stop me. Okay, so maybe the most common rule in practice is the proportional rule, okay? So the proportional rule makes awards proportionally to claims. For instance, let me show an example. Suppose here we have 3 agents or 3 firms, 1, 2, 3. Suppose that the valuation value, the liquidation value, sorry, of the firm is 1 unit, and creditor 1 claims 1 unit, creditor 2 units, and creditor 3 units, right? So according to the proportional rule, the player 1 obtains 1/6, right? Because the aggregation of the claims is equal to 6. The player 2 obtains 2 divided by 6, or 1 divided by 3. And the third firm obtains 1/2, right? This is the most common used rule in practice, okay? Of course, the proportional rule is not the unique bankruptcy rule. Other well-accepted rules are the constant equal award rule or the constant equal loser rule. The constant equal award rules try to equalize the awards among agents, but subject that no one is receiving more than his claim. Okay, for instance, in this example, the consent equal award rule is divided 1 unit equally among agents, because none of them obtain more than his claim. Right? For instance, the player 1 obtained 1 divided by 3, which is less than 1. The player 2 obtained 1 divided by 3, which is less than 2, and the third player obtained 1 divided by 3, which is less than 3. Right? But for instance, if the claim of agent 1 was 0, the constant equal losses will be player 1 0 and player 2 and 3 share equally 1 unit. That is 1/2 and 1/2. Right? Okay, another classical rule is the constant equal losses, that equalize losses with respect to the claims and the assumption that no one is receiving a negative payout. Okay? So for instance, in this example, but this rule is a little bit more complicated to calculate, but the idea is that we try to minimize the distance from the claims and equalize losses, right? So here player 1 and 2 get nothing, and all the unit is for player 3, right? Okay. The proportional rule, the constant equal award rules, and the constant loser rules are particular cases of the so-called parametric rule, right? Okay, so the objective in this paper is to characterize a rule from an axiomatic point of view. Means that we find a set of properties or axioms that fix the solution, right? So we in this paper we provide 2 new axiomatic characterizations of the proportional rule, making use a weak form of non-manipulability. Right? Non-manipulability is a well accepted property in economics in general, right? And in particular in bankruptcy problems, we say that the rule is not manipulable is we have a group of agents that merge and act as a single player, or one player is split in a number of fictitious agents. Then the agents that are not involved in these merging or splitting operations obtain the same amount, right? This is when we say that the rule is not manipulable, okay? If the rule is satisfied budget balance, non-manipulability together with budget balance is equivalent to impose that the agents that participate in these operations in aggregate terms obtain the same quantity, the same amount, right? Yes? Okay. For instance, let me show an example. I suppose that we have three firms, 1 unit to share, and three players, okay? Player 1 claims 1 unit, player 2 2 units, and player 3 3 units. Okay, and now suppose that player 3 splits into player 3 and 4, okay, and shares his claim equally. And now form a new bankruptcy problem where the set of agents is 1 2 3 4, right? The state is the same, and the vector of claim is player 1 and player 2 have the same claim as before, and player 3 and 4 share 3 equally. So player 3 claims 1.5 units and player 4 1.5 units, right? So if we calculate the proportional rule in this new rationing problem, note that player 1 obtained 1 divided by 6, okay? But the sum of the claims here is also 6. Player 2 obtained 2 divided by 6, or 1 divided by 3. And player 2 and 4 obtain the same quantity, that is 1 divided by 4, right? So that the players that are not involved in the splitting operation are players 1 and 2, and players 1 and 2 obtain 1/6 and 1/3 respectively, as before to split, okay, 1/6 and 1/3, right? So it is well known that the proportional rule is not manipulable. Okay, but according to the constant equal hours rule, player 1 and 2 obtain 1 divided by 4, 1 divided by 4, and before to the splitting operation, player 1 obtains 0 and player 2 obtains 0. So the constant equal hour rule is manipulable, okay? Because the agents that are not involved in the splitting operation obtain a different amount, okay? And the third rule also is manipulable, because player 1 obtains 0, but player 2 obtains 2 divided by 3, and before player 2 obtains 0, right? So this example shows that the third and the third rules are manipulable, and it is well known that the proportional rule is not manipulable, right? In general, right? Okay. Okay, this is the explanation of the example. So, okay, the proportional rule has been, whether I characterize it making use of non-manipulability property in the literature. Okay, so the first one was O'Neill, that characterized the proportional rule using non-manipulability together with budget balance and 3 additional properties: anonymity, continuity, and dummy axiom. Okay, anonymity says that the names of the agents are irrelevant, so the only important feature in order to distribute the state are the claims, right? Continuity says that a small variation in both the state and the claims implies small variations in the final distribution, right? Means that, formally speaking, that the solution has a regular behavior, okay? There is no gaps, right? And the dummy axiom and null consistency say that if one agent have a 0 claim and leave the problem, then if you apply the solution in the new reduced problem, where player with a 0 claim leave, then the other players obtain the same amount. This is null consistency, right? Okay, later, Chun is here. Later, Chun show that dummy axiom is redundant. Redundant means that can be the dummy axiom can be derived from non-manipulability, budget balance, anonymity, and continuity. That this is not necessary in the dummy axiom, right? When you characterize a solution, you must to prove that you need all the properties. This means that they are not redundant, okay? Right? So, and later, Chun replaced anonymity, show that dummy axiom is redundant, and later María Ángeles de Frutos, maybe you know María Ángeles de Frutos, show that replace anonymity and continuity but non-negativity, which non-negativity says that ours should not be negative, right? Okay, more recently, Yu and the other authors, okay, relaxed the axiomatization of the Frutos and replacing non-negativity by one-side boundedness, which says that the payments are bounded from either above or from above or below, right? So this is weaker than non-negativity, because non-negativity implies that payoffs are bounded from above, right? No, from below. Below is abajo. From below. Okay, from below, because they are either equal to 0, right? This is an upper bound, right? So non-negativity implies one-side boundedness. This is a technical property, okay? And they use also a weak form of non-negativity or non-manipulability, allowing mergers or spin-off by pairs. That only is possible to merge 2 agents or 1 agent split into 2. Okay? Okay, this is the theorem of the Frutos. The Frutos says that the proportional rule is the unique bankruptcy rule that satisfies budget balance, non-manipulability, and non-negativity. Okay, and the Yu Miyagawa Sakai show that the proportional rule is the unique bankruptcy rule that satisfies budget balance, pairwise non-manipulability, and one-side boundedness. The theorem of Yu is better than the theorem of the Frutos because budget balance is the same property, but pairwise non-manipulability is weaker than non-manipulability, and one-side boundedness is weaker than non-negativity. So this means mathematically is better the second characterization than the first one, right? Okay, so in our work with Pedro, we impose a weaker version of non-manipulability, just imposing restrictions on coalition formation, allowing mergers or spin-off by clones. Two players are clones if they have the same claim, right? So we impose that only can merge agents with the same claim, or one agent can split into a number of identical agents in the same that they have the same claim, right? Okay. Non-manipulability by clones says that under these conditions, no, the agents that are not involved in the merging or splitting operation obtain the same amount. That is, they don't take advantage by merging or splitting, right? Okay, and in this case, under budget balance, non-manipulability by clones plus budget balance implies that the agents that are not participating in this operation in aggregate terms obtain the same amount. But the reverse implication is not is open. We don't know if we only focus on players that are not merged instead of the players that are not involved in this operation, together with budget balance implies non-negativity, non-manipulability by clones. Okay. A technical issue. Okay, and we have I think it's a nice result. And this means that if we suppose that only consider bankruptcy problems where the claims of the agents are zero or positive rational numbers, a positive rational number is just a number that can be expressed as a division of natural numbers, which is the most natural situation. So no player claims the square root of 2, right? Or E, the number E, right? So in this case, we show that non-manipulability by clones plus budget balance characterize the proportional rule. So if we want a rule that satisfies budget balance plus non-manipulability by clone, the unique rule is the proportional one. It's nice, no? Almost non-manipulability by clones characterize the proportional rule. Plus budget balance, which is a natural claim. Okay, but in general, if we allow that agents have irrational claims, right? For instance, square root of 2, then these two actions do not determine the proportional rule. So, this is for instance, this rule satisfies budget balance and non-manipulability by clones, but is not the proportional rule. The rules say that, okay, if we have a bankruptcy problem and the aggregation of the non-negative rational claims, okay, this one is less or equal than the total estate, then the beta star rule is just the proportional one. Okay. Otherwise, if the disaggregation of the positive rational claims is strictly greater than the total estate, then players with a non-rational claim get 0, and the remaining players are paid proportionally, but according to the positive rational claims. Okay, it's a little bit tricky, but it shows that the rule is different from the bankruptcy rule, and not characterize and satisfy, budget balance and non-manipulability by clause. So if you want to characterize the proportional rule in the big domain, including non-rational claims, we need more properties, right? We need to add something, okay? This, I forget the example. We add a property. A first property we impose is claim monotonicity. Claim monotonicity simply says that if we have two bankruptcy problems with the same claim, with the same set of agents, the same estate, and only one player have an increase in claim, for instance, the player I has C prime I is strictly greater than Ci, right? So we say that the solution satisfies claim monotonicity if this player does not obtain this player, is our should not decrease. So the payoff of this credit should not decrease, right? Okay. Okay, then budget balance, non-manipulability by clause, and claim monotonicity characterize the proportional rule in the full domain of bankruptcy problems. Okay. Yes. But it's a little bit theoretical, but. Okay, another property we impose is claims continuity. Claims continuity says that we have, basically says that if small variations in the claims implies a small variation in the final outcome, in the final distribution, right? But the total estate to distribute is equal, it is not, is fixed, okay? Only move the claims. Okay, so if you replace claim monotonicity by claims continuity, they obtain a new axiomatic characterization of the proportional rule. And the proportional rule is the unique rule that satisfies budget balance, non-manipulability by clause, and claims continuity. Right? Okay, when you characterize a solution, you must to show that the properties are independent, and these properties are independent. And also you must to compare your results with the results in the literature. Okay. So for instance, with respect to the frutos, we use a weak form of non-manipulability, which is non-manipulability by clause. It's weaker than non-manipulability that use the frutos. While non-negativity and either claim monotonicity or claims continuity are not comparable, right? So that there are rules that are non-negativity but not claim monotonicity, or claim monotonicity and the other way around. Okay, there is no logical implication between these two properties. Okay, and regarding the use result, of course, one-side boundedness is weaker than claims continuity, but clearly, one-side boundedness does not imply claim monotonicity, but the reverse implication remains open. So we don't know if claim monotonicity implies one-side boundedness. Okay. And of course, beta stars satisfy non-manipulability by clones, but not pairwise non-manipulability, which shows that the non-manipulability by clones is not stronger than pairwise non-manipulability. And okay, it hasn't been yet if two pairwise non-manipulability implies non-manipulability by clones, right? That's all. Travis, queda un poco. Maybe people have a different perspective from the research, no? Not all the research is use econometric models, and remember that without theory there is no application, right? This is
my question is, to what extent these results can be used, for example, in international agreements of
yes, of course.
So my
practice. For instance, now there are a lot of papers on how to distribute the CO2 rights emissions among contents, but and apply these kind of rules. But what is important is not just to propose a particular allocation, but show what kind of properties determine this allocation, because this is the way to justify a distribution, right? So say, okay, the proportional rule, what? The proportional rule, which properties satisfy? And the axiomatic approach, in fact, is very, very important.
Yes,
very,
and
very
non-manipulability is also important, because if you are claiming, for example, say as a country, and you can split, no, let's do by regions of a country.
Yes,
for example,
this is a good question.
Because I think that this rule can be manipulable by this, and so you have to be aware.
This is a very good question.
If you are on the other side of the country and say no.
For instance, in order to distribute the CO2 rights emission, this is a very good question. And so the only rule that is not manipulable is the proportional one.
Yeah.
So it's not the same, for instance, to share per capita or to share taking account the whole population, right? So this is very, very important point, the non-manipulability issue.
In environmental problems, this is, I think that this can be very useful.
Yes.
Because many of the environmental problems are environmental goods,
Exactly.
public goods with public access, and common goods with.
Absolutely. Korea and Czech have different applications.
Yes,
on this
I know.
topic.
Yeah.
But here you have talk about the claim, but not about the individual characteristic that may explain the claim.
No, a claim is a right? It's not, that is, people does not claim what they want. It's just a right.
Okay.
All right.
A right, a derecho, right.
So you don't decide your
I
claim.
understand you.
Sorry.
Yeah.
So the claim is previously decided.
Sorry?
So you don't decide your claim. Your claim is decided previously.
Yes, and theoretically the claims are rights. And how to measure a right, this is I don't know how to do this.
For example, in a river basin, una comunidad,
yes.
This can be very useful to share the quantity of water.
For instance, yes. For instance.
Yeah, but you have to decide the claim first.
Yeah, but because the actual claims in the river basin in general are not efficient, because they are based on traditions and riparian rights and this kind of issues. So this could say, okay, if rights don't follow this kind of of properties, then
there is a property, the anonymity says that the only important is not the people, the player. So you and I are the same if we have the same claim. Not because my name is Francesc Llerena and your name is, right?
My name.
And so it's a very important property. Another property stronger than anonymity is equal treatment of equals. That says that if both have the same claim, we must receive the same amount, right? So in irrigation community, for instance, if two agents have the same demand, they should receive the same quantity of water, for instance, right? But this is very, very useful in practice. But the problem is people don't know this kind of rules, no? Well, usually people use proportional rule. But the important is why proportional rule is a good. Well, good depends on the environment, on the context, right? But
because it is the easiest one, so it's.
Sorry?
It is the easiest one, so it's the simplest way to.
Yeah, it's the simplest way, but it has a lot of good properties.
And it's also acceptable.
Yeah.
By
everybody.
A majority.
Understand the rule.
Yeah, it's a fair treatment for all.
Yeah.
Okay, so thank you
Excellent.
Thank you.
very much for being here and to